How long do you think it takes to build a skyscraper? 1 year? 2 years? Maybe even longer? If you look at China, the answer might surprise you. Just 28 hours and 45 minutes. That's how long it took Broad Group to assemble a 10-story tower using prefabricated steel modules manufactured in a factory. But while China has focused on pushing construction speed to the limit, American engineers have been pursuing a very different path. They're using robots to print houses, they're automating construction sites, and looking even further ahead, they're developing technologies that could one day build structures on the moon. This isn't science fiction, it's the story of how America is experimenting with the future of construction. In reality, high-tech construction is nothing new. Broad Group has spent years moving much of the building process into factories, manufacturing steel modules, and transporting them to job sites for assembly. The results are remarkable. 10 stories completed in 28 hours, or a 57-story tower assembled in just 19 days. However, this approach still depends heavily on construction crews, massive cranes, and traditional material supply chains. Meanwhile, many projects in the United States are focusing on automation, disaster resilience, and energy efficiency. One of the most notable examples can be found in Florida, a state regularly hit by some of America's most powerful hurricanes. In Wellington, Palm Beach County, a 10,100 square foot structure was created using three-dimensional printing technology. It is one of the largest monolithic three-dimensional printed structures ever built, with most of its structural components completed in just a few weeks by the about.At robotic printing system. What's remarkable isn't its size, it's the design. The building uses a double-wave wall system with hollow cavities inside, creating natural airflow channels that significantly reduce cooling demands. According to the design team, energy savings can reach as high as 60%. The structure also meets HVAC standards, the requirements for the highest hurricane risk zones in the United States. With construction accuracy within less than 1/10 of an inch, the robotic system produced a structure that is durable, energy efficient, and considerably less expensive than many traditional construction methods. However, the three-dimensional construction industry still faces a major limitation. Most current printing systems must operate inside fixed gantry frameworks. That means the size and shape of a building are ultimately restricted by the dimensions of the machine itself. Icon, a technology company based in Austin, Texas, wants to change that. The company developed the Phoenix robot, a construction system that eliminates the need for a fixed gantry framework. Using a nearly 50-foot robotic arm mounted on a central tower, Phoenix can create domes, curved roofs, and complex architectural surfaces that many traditional three-dimensional printing systems struggle to produce. With accuracy measured at less than 1 millimeter, Phoenix can construct a multi-story building with only a handful of technicians overseeing the process. According to Icon, construction costs can be reduced by as much as 30 to 50% compared with many conventional building methods. But America's ambitions don't stop at robotic home construction. In Milwaukee, the Ascent Tower is demonstrating a completely different path forward. Standing approximately 282 feet tall with 25 stories and 259 apartments, it is one of the tallest timber buildings in the world. Ascent is built using mass timber, combining glulam structural beams and columns with cross-laminated timber, or CLT, for floors and walls. These components are manufactured in factories and then transported to the construction site for assembly, significantly reducing construction time. One of the most surprising features is its fire resistance. When exposed to flames, the outer layer of glulam chars and forms a protective barrier around the core, helping preserve the structural integrity of the building. As a result, the tower meets strict safety requirements for high-rise construction. If China is accelerating construction through steel modular systems, the United States is experimenting with a different version of the same idea. high-rise buildings assembled from advanced engineered wood. But all of these projects still have one thing in common. They're being built on Earth. On the Moon, the challenge becomes far more difficult. Transporting construction materials from Earth is enormously expensive, which is why NASA and ICON launched Project Olympus with a bold objective: use the Moon's own surface material to build lunar infrastructure. The plan relies on lunar regolith, the fine layer of dust and rock covering the Moon's surface. Robots would melt the regolith using high-energy heat sources, transforming it into a new structural material without requiring concrete, cement, or water from Earth. Because communication signals between Earth and the Moon experience delays, these construction systems must operate largely on their own, using artificial intelligence and computer vision. Early tests conducted in Texas have already demonstrated the potential to create landing pads, radiation shields, and protective habitats for future lunar missions. So if the technology already exists, why hasn't it appeared everywhere across America? The answer lies in building codes, permitting requirements, and the natural caution of the construction industry. But rising costs, labor shortages, and growing pressure to reduce emissions are accelerating the transition. From hurricane-resistant three-dimensional printed homes in Florida to timber skyscrapers in Milwaukee to robotic construction systems designed for the Moon, the construction industry is evolving in ways that very few people could have imagined just a few decades ago. If you enjoyed this video, be sure to subscribe so you don't miss the next technology story. And leave a comment below. Would you be willing to live in a house built entirely by robots?